Let's talk about bearings. Alright, now, a bearing is the angle from your ray to the north-south line with your, oh goodness, what am I looking for? Your directions. There you go, directions. Okay, now, first of all, let's look at this one. This ray is in your northeast quadrant, so you'll say northeast. But here we have to include our theta value, our angle. The angle is from your ray to the north-south line. In this example, it says that it's 40 degrees, so that this will be north 40 degrees east. Let's talk about this example. This ray happens to be in my northwest quadrant, so it's going to be north, angle, west. And again, the angle is from your ray to the north-south line, and it states that here it's 65 degrees. Here we have a ray. It's in my southeast quadrant, so I have south, angle, east. Here again, it's your ray to the north-south line, and here it's telling you it's 70. Let's do a couple of examples. Here's an example. I'm going to zoom in on this so we can see it a little bit better. Okay. Let me put some measurements on here. Let's say that this is 30. Let's say that this is 10. Let's say that this is 70. And let's say that this is 20. Okay. First question. What is the bearing from O to B? From O to B. From O to B. What's the bearing? Okay, now, my O to B line is where? It's in my northwest quadrant. So I have north, angle, west. Now, it's from your ray to the north-south line. Here's the north-south line, so from my ray to the north-south line, that's 30 degrees. So that means from O to B, it's north, 30 degrees west. What if I want to know from O to C? Well, again, O to C, here's my ray. O to C. It is in my southwest quadrant. It has to be from your ray to the north-south line. Well, I don't have that measure. I don't have this measure from my ray to the north-south line, but can I figure it out? Absolutely. Why? Because it right here is making a right angle. Now, a right angle is 90 degrees. And if I know that this piece is 70, couldn't I figure out this small piece by simply subtracting? Absolutely. So let's do that. Let's take 90 and subtract 70. That will tell me that that little angle there is 20. So that this from O to C is south 20 degrees west. Let's see, one more. Let's do from O to D. From O to D, here's my ray, O to D. It is in my southeast quadrant. Oops. It's in my southeast quadrant. Now, again, the angle is from your ray to the north-south line. From your ray to the north-south line says it's 20 degrees. Very good. Let me zoom back out now so we can work on another problem. Let's work with a word problem here. A boat leaves the entrance of a harbor. Here's my harbor. And travels 30 miles. Here's my 30 miles on northeast 40 degrees. So I'm going in the northeast direction, and my angle here is 40 degrees. The captain then turns the boat 90 degrees clockwise. 90 degrees makes a right angle. And then he travels 20 miles. On a southeast, the south 50 degrees east. So from southeast, I'm going to go, that's 50 degrees. Zoom in a little bit more so you can see that. There we go. Okay? The question is, how far is the boat from the harbor? And then, what is the bearing of the boat from the entrance of the harbor? Okay, now what I'm going to do is I'm going to draw this picture, but I'm going to make it a lot bigger so that we can work this problem. Let's do this a little bit. There we go. Make it a little bigger. Okay. First of all, I start out at the harbor. And I travel 30 miles northeast at a 40-degree angle. Every time you do something, you want to talk about your directions. Okay? One way to remember your directions is north, never. East, eat. S, soggy. W, west, waffles. Never eat soggy waffles. Okay? Now, let's north 40 degrees east. So, in my northeast quadrant, I'm going to say that's 40 degrees. I'm to travel 30 miles. Then, I'm to what? Turn 90 degrees. That's a right angle. And I am to travel 20 miles. Whenever you turn, do yourself a favor and draw, again, your compass. Because it's stated that you turned 90 degrees and you're traveling on a bearing of southeast, so here's my southeast, at an angle of 50 degrees here. Very good. The question then becomes, oh, okay, well, if here's your boat, right, here's your little boat, the question is, how far are you from the harbor entrance? What's this distance? And also the question is, what would your bearing be to the harbor entrance? Oh, okay. So first of all, this is a right triangle. If it's a right triangle, I can figure out this side by using the Pythagorean theorem. So I have a squared plus b squared equals c squared. A squared, 30 squared, plus b squared, 20 squared, equals c squared. Now how do I know that c squared is the angle that I'm looking for, or the length that I'm looking for? Because c is the hypotenuse, and the hypotenuse is always opposite the right angle. Oh, okay. 30 squared, that's 900. 20 squared, that's 400. So I have c squared is equal to 1300. C squared, I want c, so I have to take the square root of it. But when you draw the square root, you have to put plus and minus in front of it. Well, which one are you going to take? You're going to take the positive. Why? Because we're talking about distance. Distance is always positive. So you're going to say, oh, it's positive square root of 1300. Alright, well, we usually don't say, oh, yes, I travel square root of 1300 miles to work. No, we don't say that. So we're going to take this number, and we're going to figure out what it is on our calculator by doing the square root so that we can get a more tangible value. Square root of 1300. So that's 36.06 miles. This is the distance between the boat and the harbor. Next, the question was, what is the bearing of the boat? What is the bearing of the boat? Alright, well, think about it. The bearing of the boat, we have this, you know, here, okay? Let's see, how do I want to draw this? Oh, yeah, that's, oh, well, we're going back over here, aren't we? Okay. Oh, ignore me. Okay, sorry. The bearing of the boat, now, the bearing of the boat would be from your ray to the north-south line. Well, my north-south line is here. My ray is here. So I know 40 degrees is here, but I do not know the rest of this angle here. All right. Well, I know, however, that I am traveling northeast. So I know that the bearing of the boat is north, some angle, east. Now, if you're not sure if you're drawing it right, keep in mind 30 miles is a greater distance than 20 miles, so that your line will be lifting up, okay? All right, good deal. Now, this angle here, the angle here will be 40 degrees plus theta. Oh, well, that means I have to figure out theta. So this is north, 40 degrees plus theta, east. Well, I have to figure out what theta is. Well, that's okay, because I have what? I have opposite and I have adjacent. I also have my hypotenuse. However, word to the wise, don't use your values that you come up with to find other values in the problem. Because if you accidentally make a mistake, then you're amplifying your mistake by using your wrong values. So that's just word to the wise. So I'm going to use my opposite side and my adjacent side to figure out this value of theta. Tangent of theta, that's opposite and adjacent. So I want tangent of theta, opposite's 20, adjacent's 30. Well, that means theta is equal to tangent inverse of 20 over 30. That means theta is equal to, now here's a quick question, what mode must I be in? If I'm looking for an angle theta, your mode must be in degree. Here's why. My mode right now is in radian. I'm going to show you how I know that this is going to be incorrect. Tangent inverse 20 divided by 30. We're looking for the angle. Okay? Does it make sense that your angle would be less than 1 degree? Absolutely not. That's how we know we're in the wrong mode. So what we're going to do is we're going to change our mode to degree. And now you'll see that the answer becomes, much better. So that this says that theta is 33.69 degrees. That means that my bearing is north, 40 degrees plus 33.69 degrees east. Oh, so it's north, 73.69 degrees